Good morning, good afternoon, good evening. My name is Chase Schultz. I'm with Systems Technology Incorporated, and today I'll be presenting on our work with NavAir defining unmanned aerial system handling qualities. STI was founded in 1957, so we are celebrating our 65-year anniversary here in August. Our core focus at the time was the guidance, navigation, and control space, and we remain focused in this area across a range of vehicle types and autonomy levels. We have addressed all aspects in this area, including aircraft hauling qualities, control system design and analysis, fleet dynamics, modeling and simulation, among others. And we continue to heavily consider the role of the pilot in the system and the evolving definition of the same, as new autonomous technologies have begun to make their impact felt here. Our background in flying and handling qualities and activities in the same area can be noted in our contributions to the flying quality specifications for aircraft, MIL 8785C, followed by MIL Standard 1797A, ADS-33 on the rotorcraft side, and we are actively supporting the FAA in their development of a certification means of compliance methodology for eVTOL and a supporting test guide. We've also brought two successful PC-based simulators to market, STI SimDrive, a fully interactive driving simulator focused in the occupational health and assessment space, and Parasim, a virtual reality-based, premeditated, and mission rehearsal parachute trainer. Assessing the handling qualities of UAS has presented a unique challenge. Traditional methodologies relied on pilot commentary and application of the Cooper-Harker rating scale to make and drive these assessments. These were based on the precision and effort of the pilot performing a given task. But what is to be done when the pilot may not be directly in control of the vehicle, piloting it like a traditional aircraft, or when the system is autonomous and there's no pilot involved? The core of the work performed here for the Navy is meant to address those questions. This work and prior NASA efforts in this space have helped us identify a mission-oriented approach as a solution, guiding applicants and regulators through the assessment process and two relevant handling qualities requirements. These requirements and the performance of the vehicle relative to the same is what would inform the overall assessment of the UAS and provide additional input to the decision makers as to whether to integrate a given vehicle into a test or operations environment. We expect our initial transition targets to be the MQ-25 and MQ-8 B and C platforms, among others. And we are currently crafting a software toolbox to guide relevant parties through the mission-oriented approach to predict handling qualities via simulation and analysis, followed by the verification of those handling qualities predictions through flight tests leveraging mission task elements and the mission-oriented approach. The need for such a process and toolbox was born from the reality that the current certification and acceptance processes for current and new UAS to enter the naval airspace and operations are not well defined. These assessments have been based on past experience, lessons learned, and adaptations of existing manned vehicle requirements and techniques. Nothing has been formally codified to address and fully assess the validity of these approaches and ensure that there is coverage of potentially unique UAS assessment needs. The Navy has asked for a toolset and specification that would provide them clear guidance to perform the necessary evaluations of these vehicles and make a more informed and focused decision. Our current end users, NavAir and the broader Department of Defense, we would expect this process and tool set to also eventually integrate with the manufacturers and designers as the Navy is looking to apply this process to the assessment of their vehicles. What will be required here to see it successful, at its core, is additional data, input, and financial support to fully realize a specification and requirement set that has validity and eventually begins to cover things such as failure modes and degraded conditions. The pilot specifications, MIL Standard 1797 and ADS-33 have evolved over decades and through multiple flight test programs across a range of vehicles. This database does not exist today for UAS, and some version of this will be required to develop a truly informed specification. This work for the Navy is focused on creating a digital UAS specification and test guide. In addition, we are creating a companion software toolbox to guide the end user through the handling qualities prediction and verification process. As mentioned previously, and a big need for this effort, is an appropriate test database to inform the various requirements. While piloted aircraft requirements can be a starting place in some instances, they do not and should not define the final requirements, or at least they should not, without having been checked against UAS-specific vehicles. Our current specification effort will be informed by the X-47B test campaign and existing MQ-8B and C databases. Our partner, Penn State University, will be gathering additional rotorcraft data, but these databases represent 1 to 2 examples of 2 types of vehicle only. Further information across a range of test conditions, vehicle types, configurations, and scenarios will be required to truly validate the preliminary bounds that will be set here. The key enabler of this work and what will permit its broader application is the STI-originated mission-oriented approach. This methodology breaks down a vehicle mission to specific mission task elements with well-defined performance requirements that are meant to verify mission effectiveness and safety. For example, as a part of the usual mission of a rotorcraft, it will be expected to hover. A hover task would then be defined as a mission task element, and a specific maneuver and associated requirements defined to formally assess the vehicle performance. The current status of this effort is as follows. We have developed a draft UAS handling quality specification that is being tailored to Navy applications. In support of that work, we've also drafted representative mission task elements for their different mission scenarios and performed an initial survey of the MQ-8B and C and X-47B datasets. Those datasets have been assessed both to develop those mission task elements and also explore the data available that could be applied to candidate requirements boundaries. The rotorcraft flight test program at Penn State University is also underway, and an alpha version of the UAS HQ software toolbox has been developed. The toolbox will be updated as the data is assessed, and relevant mission task element requirements and requirement boundaries can be established or updated. This work originally began as a NASA Phase 1 SBIR, then Phase 2 program, before being picked up by NAVAIR as a direct to Phase 2 program to consider more Navy-relevant applications. The option to the Navy program is ongoing now and will result in a test guide and companion software toolset for integration into the NAVAIR UAS assessment process. A key advantage that this work provides is a set of candidate requirements and boundaries that are specific to UAS for a given vehicle mission and that are not simply adaptations of the existing unmanned system requirements. Any application of those requirements will have been made with adjustments based upon available UAS data and not as a blind use of the existing values. In addition, as UAS are by definition unmanned, their requirements will be independent of any pilot comfort or other control methodology assumptions that are present for the existing piloted vehicle requirements. These insights will be summarized in a central UAS-specific handling quality specification and test guide with supported mission-based test and evaluation approaches. This has the benefit of supporting a formalized process for fleet integration that will increase the speed of this activity while decreasing the 3 core issues in cost, schedule, and technical risk. The software that goes along with this will facilitate the application of the specification, providing a common framework for all assessors to work through within and throughout the design process. As discussed previously, the UAS handling quality assessment process described here considers both the predicted and flight verified handling qualities of a vehicle. This toolbox facilitates the repeatable and traceable specification compliance throughout the development process and then informs the test activity planning through these analytical assessments. In order to support a complete specification and test guide, we are asking both the Navy and the UAS community at large for additional data and funding support to continue and expand the developments described herein. Navy-relevant data should include and address different vehicle configurations and types, as well as cover a range of mission task elements. The data should also cover a range of pilot-operator involvement and autonomy level in the operations of the vehicle, and if possible, failure modes and envelope protection schemes. All of these and more will be required to be understood to develop a full picture of UAS handling qualities and associated considerations. Both the specification and toolbox will benefit from these data sets and further the effort. Mr. Matt Reinhardt, the Flight Dynamics Branch Head, Air Systems Group, Air Vehicle Engineering Department at the Naval Air Warfare Center Aircraft Division, has been our primary transition advocate and has identified the need for the specification and toolbox. With his support, we have engaged PMAs responsible for the various UAS platforms to seek their financial support for a Phase 2.5 and beyond program, with the ultimate goal of creating a tri-service UAS specification. The specification, test guide, and companion software form the core of a new productized service where we provide the customer the software toolbox and test guide, and then work with that customer to support their test and assessment efforts. This support will include things such as test plan development, execution, data reduction, and analysis, in addition to any other GNC-related activities and needs that we here at STI already provide. The transition and introduction of this new productized service will be enabled through the adoption of the specification, test guide, and toolbox by naval procurement and science and technology authorities at the PMAs, in addition to prime military UAS contractors. As mentioned previously, additional funding and support through test data and other related activities will be required to properly define and validate the requirement bounds and software that form the core of this new service. Thank you for your attention here today, and while I'm sorry we won't get a chance to meet in person as the event has now gone virtual, I'd encourage you to please reach out via email or phone if you have any questions related to these activities or any of the other guidance, navigation, control services we provide. All the best, and thanks again.